is Arun, and we are here to talk about Azure DevOps pipelines. So, let's start with understanding what it is and all the functionalities and the features. So, Azure DevOps pipeline is a feature of Azure DevOps Suite that we talked about in the first video of Azure DevOps series. Like the first video, this is the third video. So, these pipelines supports CI, which is continuous integration, and CD, which is continuous deployment strategies. It allows you to automate the process of building, testing, and deploying your code to various environments. And here is a detailed breakdown of these features and functionalities, which I have highlighted here. So let's talk them one by one. Let's understand them one by one so that we can use this knowledge of all these features and functionalities in our scenario. Because in the next slide, I have prepared a scenario where we can or we have to go ahead and prepare something for some scenario with the help of these functionalities just to cement our knowledge. So CI is a software development practice where developers regularly merge their code changes into a central repository, after which automated builds and tests are run. The primary goal of CI are to find and address bugs quicker, improve software quality, and reduce the time it takes to validate and release new software updates. And these things we already talked about on a high level in our very first video. But since it is here, it's a part of pipeline, so I have to go through again. And there are a couple of things that will get repeated again. Do not worry, it helps us to get it into our memory. So let's go through the workflow of CI just to understand it better. We now know what it is. Now let's see how it works in a real environment. So a developer works on a new feature, let's suppose, in a separate branch on their local machine. Once the feature is complete, they commit their code to the branch and push this branch to the central Git repository. The push to the repository triggers the CI pipeline in Azure DevOps. The pipeline automatically builds the application, ensuring that the new code integrates correctly with the existing code base. And the pipeline then runs a series of automated tests, unit test, integration test, and so many other kind if you have implemented on the application. If the build or any test fails, the developer is notified immediately and they can quickly fix the issue. If everything passes, the new code can be considered stable and ready for integration into the main branch or for further stages like deployment. So that's the simple workflow on a very high level, just to understand CI. Now, in continuation with the CI, what we're gonna do after the CI, we receive build or artifact. And in continuation with that, CD happens, which is continuous deployment, which is a software development practice that takes the concept of continuous integration further by automatically deploying all code changes to different environments and finally production. It's critical part of the DevOps pipeline, enabling rapid delivery of features and fixes. Right? Yeah, that's what we are trying to do ultimately by using Azure DevOps or Azure DevOps pipeline. So what would be the workflow for this CD? Well, once the CI pipeline successfully completes, the CD pipeline is triggered automatically. The CD pipeline deploys the new version of the application to the production servers. This could involve steps like updating server-side application, applying database migration, or clearing cache, Like any steps may be involved, but the point is, even if, let me clarify this, it may or may not be deploying directly to the production. You might have one many environments in between, like staging, pre-prod, dev, and you can have the pipeline that long. If that stage is successful, then it will go to the pre-prod and then prod. Entire process can be automated. If the build and test passes, the code goes straight to production without manual gates. Well, to achieve that performance, that fully automated pipeline, at the beginning, you need to put a lot of effort, because if you remember, confidence comes. Remember the previous video, from the knowledge and the practice. Once you have the proper knowledge how things work in the pipeline, once you have practiced in their environment, once you are sure, because you are going to touch the production automatically, though there could be manual approvals, although anyways, that's what the CD process is, which is again the offering of pipeline. Now let's, because this DevOps pipeline gives you YAML, uh, what we say, code to write the pipeline. Hence, we need to understand the pipeline structure. So a pipeline is a set of automated process for building, testing, and deploying code. We understand that. And in Azure Pipeline, we can define these processes in YAML file. That's why we also call it pipeline as a code. You could also utilize Azure DevOps user interface to do that, right? So let's, but the pipeline as a code, because we're talking about automation and DevOps. So of course, pipeline as a code always wins because it has other benefits as well. So let's try to understand the pipeline structure first. So in generally, it has two main parts, as we can easily understand: the CI pipeline or build pipeline, or CD pipeline or release pipeline. So CI pipeline automates the process of compiling code and running test. It ensures that the code integration is successful and the code is ready for deployment. And CD pipeline manages the deployment of the code to various environments like testing, staging, and production, which is must. Do not just simply deploy in the production. Of course, that's the pipeline structure on a high level. But if you go deeper, we have stages. Stages represents a phase of pipeline like build, test, or deploy. Each stage consists of multiple jobs. That's how you write the YAML file. First, you have stage, and in stage, you have multiple jobs. For instance, you might have a build stage followed by a test stage, and then multiple deployment stages for different environments. Okay, then what is the job then? Well, a job is a collection of steps that can run sequentially on the same agent. You can have multiple jobs within a stage. A job might include steps like checking out the code from the repository, compiling the code, and running the unit test. Now it's clear. And there could be multiple steps there. Steps are the smallest building blocks of a pipeline and consist of tasks or scripts to be executed. A step could be a script that executes a set of commands, a task that publishes artifacts, or a task that deploys code to a server. And how these things will happen? An agent is a computing infrastructure where the pipeline runs. It could be either hosted by Azure DevOps, that is Microsoft hosted agent, or set up by you, which is self-hosted agent. Agents execute the jobs defined in your pipeline. You can specify the type of agent based on the requirement of your project, and like a specific operating system, of course. And this could be a part of your pipeline as a code. That means YAML, because that's what we are talking here, YAML structure. And finally, artifacts. Artifacts are the files produced during the build process, like compiled code, logs, or packages that are used for deployment for the next step in your pipeline. They can be published, consumed, and stored within Azure pipeline. But why we are talking artifact here? Because these two are the part of pipeline structure. So output of CI is artifact, that would be the input for the CD. I hope this makes sense now. Now, triggers, because how this is going to happen? We're just writing code, so there must be triggers. So, triggers are conditions or events that automatically start a pipeline run. Common triggers include code commits or pull request creation. You can set up a trigger to start the build pipeline whenever a developer pushes a code to main branch of the repository. And you could choose any other way that fits your environment. So that's all about pipeline structure. Now it offers multi-platform support as well, like build and deploy on different operating system like Windows, Linux, and Mac OS, or build a cross-platform application that runs on both Windows and Linux. It also supports container and Kubernetes. For container support, we have like build, push, and pull Docker containers. And if we talk about containers, and for Kubernetes integration, we can deploy to Kubernetes cluster, including Azure Kubernetes Service. Uh, it also provides us extensibility and integration because we have marketplace extensions, integrate with a wide range of tools and services through extensions available in the Azure DevOps marketplace, just like integrating with Sonar, Cube, or Cloud for code quality analysis, which is the most common I have seen, or add custom scripts in various languages like Bash, PowerShell to your pipeline steps. That's how it is extensible. All right, then we do have a way to manage sensitive information like API keys and passwords. Passwords like store database connection and strings securely and use them in the pipeline. We can also integrate through the Key Vault. We can keep track of changes, deployment, and access to ensure compliance with company policies and regulation. All these things will help in the security and compliance. And real-time insights that we can get through the monitoring. We can monitor the progress of builds and deployments in real time. Because Azure DevOps offers all those things like a dashboard, it displays the status of recent pipeline runs, succeed, failed, in progress, and can show trends over time. Build and release logs. These logs include every step of the pipeline, providing insights into what happened during a build or release. We can also set the notification and alerts on various pipeline events, like you can configure alerts for events like build failures, release, or approval needed. Azure DevOps Pipeline can publish and display test results and code coverage matrices after each run. You can view detailed test results, including passed, failed, and skipped tests. Azure DevOps provides analytical tools for deeper insights into the pipelines and generate reports on various aspects like build duration, success rates, deployment frequency, and many more. It can be integrated with external monitoring tools, though it falls under the integration. But yes, under monitoring, you can again have that integration with the external monitoring tools like Azure Monitor, which there is a seamless integration. You can also keep the audit logs for compliance and diagnostic purpose. So there are so many features under monitoring and reporting as well. In all of these, and agent pools, as we said, they are like two ways. We can use Microsoft hosted agents for building and deploying, uh, or set up our own agents for special requirements. We can have all detailed conversation in upcoming videos, but for now, we have to cover this one, what we have prepared for this video. So I hope this gives a pretty good, decent idea about the Azure DevOps pipeline features and functionalities, and it will be more clear with the scenario. Well, I find it very helpful, examples and scenarios to understand any theory, anything that we try to understand. So here is the scenario. What is the scenario? So let's consider a scenario involving a software development team working on a web application. This team wants to use Azure DevOps pipelines for continuous integration and continuous deployment. And let's go through end-to-end cycle, highlight how various features of Azure DevOps pipelines can help here, as I have highlighted already. So what is the project? A web application deployment using .NET Core backend and React frontend. Repository is Azure DevOps Git, an environment we are planning, development, testing, staging, and production. All right, so let's start with the source code. Developers push their code to feature branch in the Azure Git repository. That's what they're using, as you can see in this scenario. Azure Pipelines is directly integrated with the Azure repos for obvious reasons, or maybe you could think from the trigger. Once the code goes there, trigger initiate and pipeline initiates. The CI pipeline is triggered automatically. That's what the trigger we have applied here, or thinking to apply here, whenever a pull request is created against the main branch. Then the pipeline is defined in Azure Pipelines YAML file. We talked in detail in the previous slide. At the root of this repository, we compile the .NET Core backend and React frontend. And the artifact, the build artifact, compiled binaries, front end build are published for the deployment. And then, of course, there is a testing. That's what all about pipeline. But now it's about testing. That will fall under pipeline, of course. But testing is something which is very, very important and it's a crucial part of CI. If there is no testing, then of course you are just kidding yourself with using the CI. The very first is there are multiple ways, but let's go through the ways first. I think it's important to talk about here. All right, let's do this. Integration test, which is test the integration between integrated units, modules of the software to detect interface defects. Uh, Here we can run backend integration test using a test database, right? Because we do have that software. So integration test can be done here. There is another kind is unit test, where we test the individual components or function of the software in isolation. And here we can think as an execute front end unit test. We can also have functional test. Test each function of the software by providing appropriate input and verifying the output against the functional requirements. Ensure that the new code changes have not adversely affected the existing functionality of the software, which is regression test. End-to-end test to test the entire application's workflow from start to finish to ensure the system behaves as expected. Assess the speed, responsiveness, and stability of the software under a particular workload, which is your performance test, and identify vulnerabilities and security holes in the software under the security test. Analyze the source code and detect potential coding errors, bugs, uh, uh, errors, and suspicious constructs through static code analysis. Perform UI test to test graphical user interface to ensure elements are visible and functional as expected. Smoke test to perform basic test run on each build to ensure the most critical functions of the application work. So as you see, there are so many tests involved. You can utilize test, which is absolutely important for your application, which is integration, of course, and unit and functional test, which I have seen like these three always, and security, of course. Or you could utilize different tools for the security just to check. So the test results are published and visible in Azure pipelines. Integrating these tests into a CI pipeline helps catch issues early, reduce bugs in production, and ensure that the software meets both functional and non-functional requirements. This leads to higher quality software, improved user satisfaction, and a more efficient development process. After this successful testing and execution of CI pipeline, we gotta have CD, which automatically triggered after a successful CI build when changes are merged into the main branch. So you see the workflow we talked about in the previous slide. Here it is coming in realistic scenario. So separate jobs or stages for development like testing, staging, and production. Uh, we can have manual approvals required for deploying to staging and production. because approvals is also part of these pipelines for CD pipeline deployment. Then the deployment process include the environments, as we were talking about, development, testing, and staging, or production. So we can have automated deployment, direct deployment to a development server environment. Uh, and for testing, we have like additional automated UI test uh, under testing environment. We can mimic the production environment as a staging one, and we may require manual approval before deployment to ensure quality under staging. And finally, production. The application is deployed to the production environment, and Azure Monitor can be used to track the performance and health along with the other uh, tools and features provided by Azure DevOps that we talked in the monitoring part of the previous slide. Then finally, we have to have something for security and compliance apart from testing, because we also believe moving security to the left. So secrets and credentials are stored securely in Azure Key Vault. We are incorporating any compliance or security scanning tools which is required under CI. Then real-time monitoring for the pipeline status. We talked about all those monitoring things which is provided by Azure DevOps Pipeline along with the logs, integrating application insights, which is a wonderful tool, and it can seamlessly integrated with our pipeline. So this scenario demonstrates a complete CI/CD pipeline in Azure DevOps, covering everything from code commits, automated building and testing to different stages of deployment. The pipeline ensures that the code is automatically tested, securely handled, and reliably deployed to various environments. With oversight and control mechanism like manual approvals for sensitive stages, this process greatly enhances the efficiency, reliability, and quality of the software development and deployment lifecycle. With this, we have successfully covered this scenario. How successful? You guys will tell me if it makes sense to you how these things are interconnecting the previous slide and this one. And if it is making sense to you, then of course it is successful. If not, then I'm so sorry. Maybe we can create a different video with a different way of explaining things. Anyways, that comes later. For now, let's focus here. So what we're going to do now, we are going to see, we understood, because we understood what is DevOps pipeline, we understood the scenario, how we can utilize, but why are we doing this? What are the challenges it solves? That is the most important part. Why? Because even when DevOps was not there, things were happening, right? So why DevOps? So how we want to talk about this? Let's let's go through. Let's try to understand with the previous scenario. Okay. Using Azure DevOps pipeline, uh, we can solve several challenges. For example, code integration and quality control. The very first is this. Without automated integration, developers might work in isolation for long periods, leading to integration conflicts and quality issues when merging code. And of course, it will consume a lot of time. If something happens, some error, mistake, bug comes up, it is tough to figure it out and fix it. It's easy to merge, like when you have few lines of code rather than when you have completed, done a lot of things. So CI in Azure DevOps Pipeline automates the process of integrating code from different developers frequently. It ensures that every commit triggers a build and run test, which helps in early detection of conflict and bugs. So it's solving this challenge, code integration and quality control. Manual development deployment processes are often slow and prone to human errors, causing delays and reliability issues in production. And CD automates the deployment process, reducing human errors and improving deployment consistency across environments. Automated deployments also speed up the process, enabling faster delivery of features to users. Difference in development, testing, and production environment can lead to to the infamous, it works on my machine problem, right? Where code behaves differently in production. Azure DevOps pipeline ensures consistent configuration across environments. Infrastructure as code can be used to define environment configurations, ensuring that all environments are identical. Complex applications often have multiple components with interdependencies, making the build and release process challenging to manage. And Azure DevOps pipeline supports complex workflows and can handle dependencies between different components and stages. Pipelines can be defined to build, test, and deploy each component in the correct sequence. Without a centralized system tracking which version of the code is in which environment, and the status of various builds and deployments becomes challenging. And of course, Azure DevOps provides comprehensive tracking and reporting features. You can easily track the status of builds, deployments, and the versions of the application deployed in each environment. Organizations often struggle to balance the need for rapid delivery of features with the stability of the production environment. And of course, with the pipeline, because pipeline supports different deployment strategies like canned release or blue-green deployment, enabling teams to introduce changes gradually and safely. It also supports manual approvals and gates for additional control. Utilize the policies for the gate. All right, then ensuring that the development and deployment processes comply with security and regulatory requirements can be challenging. Yes, we understand that, but with Azure DevOps integrates with various security and compliance tools. It also supports secure handling of secrets and credentials and provides audit trails for compliance and tracking. So these are some challenges, but with Azure DevOps pipeline, we can easily solve them. So by using Azure DevOps pipelines, teams can address these common challenges effectively. It brings automation, consistency, and control to the software development and deployment processes, leading to faster delivery, higher quality, and more reliable software. This approach not only streamlines the development lifecycle but also aligns it with modern DevOps practices, making it a valuable tool for any organization looking to optimize its software development and deployment practices. And it seems really interesting, isn't it? All right, so it's time for next slide. Let's see what we have. Benefits. Yes, these are the challenges it's solving, but what are the benefits of using it? So Azure DevOps pipeline has so many benefits as you can see. Let's try to understand them. The very first is streamline workflow and automation. By automating CI/CD pipeline, business can ensure consistent and efficient building, testing, and deployment of applications. Automation minimizes human errors, leading to more reliable and stable releases. And with streamlined processes, business can deploy features and fixes faster, improving their competitiveness. And then that's all about the business, right? Everything is about the business. So it's a wonderful benefit, and everybody wants that benefit. That's why they go to the Azure DevOps. Okay, let me say it again. If you want this benefit, then adopt or embrace the DevOps to get this benefit. Do not just use it because somebody else is using Terraform. All right. So Azure DevOps pipeline integrates with other DevOps services like boards and repos, enabling better collaboration across teams inside the same UI or same suite. So dashboards and reporting tools provide transparency into the build and the deployment processes, making it easier for teams to track progress. So it's enhanced collaboration and transparency. And this Azure DevOps pipelines is versatile, supporting a range of programming languages and frameworks, making it suitable for diverse projects. It scales to accommodate projects of any size, which is crucial for business as they grow. Hence, the flexibility and scalability. Pipelines facilitate continuous testing which is essential for maintaining high quality software. We talked in detail about this testing in previous slides. So continuous integration allow for early detection of bugs and issues, reducing the cost and effort of fixing them later. And who doesn't want that? Azure DevOps provides robust security features, including secure handling of secrets, compliance tools, and integration with security testing tools. Auditing and compliance features help business adhere to industry standards and regulation and save from penalty and bad name in the market. Then, of course, automation and efficient resource utilization can lead to significant cost savings. Cloud-based pipelines can dynamically allocate resources, optimizing cost as well. Well, this DevOps culture encourages continuous improvement practices, fostering a culture of high performance and agility. Rapid deployments and integrations with monitoring tools allow for quick feedback, enabling proactive improvements. Being cloud-based, it allows teams to collaborate and access pipelines from anywhere, enhancing flexibility and remote work capabilities. Who doesn't want remote work? And yes, integrates with a variety of tools and services, enhancing its capabilities. Pipeline can be customized to fit specific project needs. Let's conclude this by saying Azure DevOps Pipeline provides a comprehensive solution for automating the software development lifecycle, from code integration to delivery. It offers a blend of efficiency, security, and flexibility, making it a valuable asset for any business aiming to enhance its IT capabilities. For IT teams, the combination of automation, ease of use, and powerful integration makes their work more efficient and satisfying, contributing to overall team morale and productivity, which is must. In the broader business context, these benefits translate into faster, more reliable delivery of software products and services, ultimately driving business growth and success. And that's all everybody wants, right? Growth and success. All right, so what do we have? We have an hypothetical architecture. I just don't remember when I click next. Anyways, it's fine. We're gonna end everything with the hypothetical architecture here because we have covered this entirely, and this is what we're gonna cover in the end. So what it is? Well, we have an scenario, and we are going to implement a pipeline in a way it should be implemented. So what do we have? We have a multi-component cloud-native application. Front-end React, back-end Node.js, .NET, database SQL, NoSQL, and microservices, as complex as possible for the newbies. All right. So, and the infrastructure we're deploying, App Service, AKS, Azure SQL Cosmos, and we're going to use Azure repos for source control. All right. So the very first point is, of course, what are we going to do? We're going to do CI, pipeline. Front-end pipeline automates the building and testing of the React application. That's our front end. Backend pipeline, separate pipelines for Node.js and .NET Core APIs, including build and test automation. Then microservices pipeline, individual pipelines for each microservice, allowing for independent development and deployment. Then we have database pipeline for managing database schema changes and updates using tools like entity framework migrations for SQL databases. Then infrastructure as code pipeline, ARM templates or Terraform scripts for provisioning and managing the Azure resources. So these many pipelines for CI and for CD, because in output of CI is the input of the CD, right? So CD, automatic deployment to a development environment for immediate feedback, development environment. Deployments after successful development test include further integration and performing performance testing under the testing environment. And our staging is mirror of the production environment. So used for final testing and stakeholders reviews in the staging environment, manual approval required for deploying to staging. And finally, deployment post-staging approval, which is production environment. Implement blue, green, or canary deployment strategies to minimize downtime and risk, or rollback strategy as well. Finally, we have Azure Monitor and Application Insights integrated for real-time monitoring, performance metrics, and logging. We have feedback integration, incorporate user feedback and monitoring data into development pipelines for continuous improvement. Azure Key Vault to manage secrets, credentials used in pipeline. We have integrate security scanning tools in CI/CD pipelines for static code analysis and dependency scanning. We make sure compliance with industry standards and regulations through automated checks and audits. Then, of course, how can we forget the boards we just learned in the previous video? Link work items to builds and deployments for full traceability. And use Azure DevOps Analytics for insights and reporting on the development process. And we can, if we want, we can use the third-party tools, integrate with external tools like SonarQube for code quality, Slack for notifications, or Teams as needed. We can also utilize marketplace extensions to extend functionality and integrate additional tools. All right, I hope it all makes sense. So in this hypothetical architecture, Azure DevOps pipelines act as a backbone for automating the CI/CD process, ensuring the software is developed, tested, and deployed efficiently and reliably. The use of containerization and Kubernetes enhances the scalability and resilience of the application. By incorporating comprehensive monitoring, security, and compliance measures, the architecture ensures that the application is not only functionally robust, but also secure and compliant with industry standards. Azure DevOps Pipelines flexibility allows it to cater to each component of the architecture, ensuring that all parts of the systems are consistently integrated and delivered. And I hope this video helped and you learned something new today. So with that, take care and bye-bye.